Hey out there, Math 8 people. Today we're going to do a very quick review of Unit 3, and we're going to talk specifically about three things. Order of operations, the Pythagorean Theorem determining if a right triangle exists. As I recall, this was something that many of you didn't do well on the test, even though it's a pretty easy thing to do. I think you just forget. And Pythagorean Theorem, finding a missing side. So let's start with order of operations. So order of operations, whenever you see a sequence, a mathematical expression that has more than one operation in it, you know that those operations have to be done in a specific order. And we use the acronym GEMS or GEMDAS to help us remember what to do. Remember that G is for grouping symbols. And grouping symbols can include absolute value, radical signs, fraction bars, if there's math in the numerator and denominator, parentheses, brackets, and braces. E is for exponents. I can see I'm going to run out of space here. And remember to be very careful about whether or not your exponent, your base is inside parentheses or not. It makes a difference. M and D are multiply and divide, and remember that you have to go from left to right. So if you have multiplication first and then division, you do it in that order. If you have division first and then multiplication, you do it in that order. You just do both of them from left to right. Same thing with addition and subtraction. All right, so addition, subtraction, it can go also from addition first, then subtraction, or subtraction first and then addition. It doesn't matter. You just have to do them from left to right. Okay. The problems that you're going to see on your activities this week are not terribly complicated. So I'm not going to run through examples with you. I'm pretty sure that when you see them, you're going to be able to do them. I just wanted to give you a quick review of GEMDAS. Next is the Pythagorean Theorem. So remember that the Pythagorean Theorem is regarding specifically right triangles. And right triangles are triangles that have a right angle in them. And remember that when you are talking about right triangles, you have two legs and the hypotenuse. And remember that the legs are the two sides that create the right angle. The hypotenuse is across from the right angle. If you draw an arrow through the right angle, you will always point to the hypotenuse. Remember, it is also always the longest side. And that is information that you need to know to do the first thing. So a couple things we can do with the Pythagorean Theorem. We can verify if a right triangle exists. So let's say, for example, that I tell you I have a right triangle, and the side lengths are 3, 4, and 5. Well, just because I draw it as a right triangle or tell you it's a right triangle doesn't mean it really is. You should verify that it is using the Pythagorean Theorem. So the theorem, remember, says that a squared plus b squared equals c squared. And a and b are always the legs, and c is always the hypotenuse. So that's how you know where to put the numbers. 3 squared plus 4 squared equals 5 squared. Well, if you want to know if this is a right triangle, just do the math and see if you get the same answer on both sides. If you get the same answer on both sides, then you have verified that yes, this is actually a right triangle, because the Pythagorean Theorem says that if it's a right triangle, it will work out this way. If I give you another triangle, and I tell you that this is a right triangle, and I want you tell me if it really is, first thing you do is identify your hypotenuse. So remember that that is the number that has to go in for C. A and B are interchangeable. So I could put 7 here and 8 here, or the reverse, it doesn't matter. And then you just do the math. And let's see, 49 plus 64, 3... I think 113 if I'm doing my math correctly. Well, 113 does not equal 81, so no, this is not a right triangle. If you actually built this triangle, it would not work, okay? That's how you verify if a right triangle exists. Sometimes they won't give you a picture, they'll just give you numbers. Like if I say 6, 8, 10, is this a right triangle? Well, you would have to substitute the numbers and do the math and see. And this is where it comes in handy to know that the hypotenuse is the longest. Whichever number is the biggest is the one that has to go for C. Do the math. If it works out the same, your answer is yes, this is a right triangle. Okay, we can use the Pythagorean theorem to help us find a missing side. Let's say that I tell you that this is 7, 12, and I don't know. So we're going to use the Pythagorean theorem to find that side. So first of all, which side are we looking for? We're looking for the hypotenuse. So since we don't know it, we have to keep it as C. A and B, however, are going to be 7 and 12. And let's see, 49 plus 144, I should have my calculator out. 49 plus 144, okay, 193. And then remember, this is not the end of the problem. The hypotenuse, we said, should always be the longest side, but it should only be the longest by a little. So it's going to be bigger than 12, but not much bigger. It might be 14 or 15, but it's not going to be 193. So what do we have to do with this 193? Well, 193 is equal to C squared. I don't want C squared, I just want C. And remember, to unsquare a number, we do the square root. So square root of 193, let's see what my calculator says. It is 13.89 and a bunch of stuff. I'm going to round it to 13.9. I can look at my triangle and check. Is it bigger than the other two sides? Yes, but only by a little? Yes. So here's my missing side, okay? We can also do this to find a leg. Let's say I have this triangle and this side is 8 and this side is 10. Whoops. Actually, I was going to say I didn't know that side. Let's say this side is 14 and this side we don't know. So this time I can see I have the hypotenuse. It's 14. So 14 has to go where C is. That means 8 can either go for A or B. It doesn't matter. The other leg has to keep its letter. Then you do the math. Let's see, 14 squared, 196. Okay. See, this is why it's handy to know your perfect squares. Now, on this case, I have B squared over here with the 64. I want B squared by itself, so I'm going to zero pair the 64. And let's see, 196 minus 64, whoops, is 132. And then, just like on the last one, your last step has to be to do the square root, because I don't want B squared, I want just B. And the only way to get that is to square root it. So let's do the square root of 132. It is 11.48. That rounds to 11.5. And I'm always going to come back to my triangle and check to see if it makes sense. Now, since 14 is the hypotenuse, that has to be the longest. So 11.5 is good because it's shorter, but only by a little bit. Okay, guys, that is it for Unit 3. This should be pretty easy activities for you. If you have any questions or problems, please email me or Miss Moore or Miss Powell, and we'll be happy to help you out through those. Hopefully you'll have a pretty easy week, and we'll see you next time. Bye.